Hello, I'm Kay Strang. You can check me out at my website quantumid.science, where you can find more detailed analysis and material on my series of 6 podcasts hunting the identity of the quantum. The previous 2 podcasts questioned the existence of quanta as distinct, discontinuous packets of energy. Not simply the radiation as in the ultraviolet catastrophe, but also in the form of the electron in the photoelectric effect, which appeared to balance the quanta of radiation. Continuing down this route of discontinuous energy, in order to obtain a functioning model of the atom, analysis had to tease out the subatomic parts and then figure out how they were related to each other. This process eventually culminated in the standard model of elementary particles. Schrödinger deviated from this line of inquiry and proposed a continuous wave theory, which I believe has more explanatory power and coherence in terms of what is physically present than the discontinuous particle theory. It fell by the wayside, and in this podcast I will show how and why this occurred. So let's look at Schrödinger's arch-rival, Heisenberg, the Salieri of physics. The professional rivalry between Heisenberg and Schrödinger is well documented, and the fact that Schrödinger's wave equation was preferred to Heisenberg's matrix mechanics must have rankled him, and he set about sabotaging Schrödinger's work in much the same way as Salieri attempted to sabotage Mozart. The 2 physicists were attempting to give a theoretical description of the motion of the electron in Bohr's model of the hydrogen atom. That is, the solar system model of a nucleus made up of one positively charged proton, making up the mass of the atom, together with a negatively charged electron orbiting the nucleus. This schematic model helped in the development of the periodic table and has been essential to an understanding of chemistry and biology, but I believe falls short in describing the physical reality. Alfred North Whitehead warned against mistaking the map for the territory, as for example thinking the London Underground map, the utility of which cannot be questioned, actually describes the network of tunnels beneath London's streets. Bohr's faulty reasoning can be found in a 1911 paper in which he states that electromagnetic waves cannot be included in the description of the atom because, quote, "This is presumably due to the circumstance that the electromagnetic theory is not in accordance with the real conditions and can only give correct results when applied to a large number of electrons, as are present in ordinary bodies, or to determine the average motion of a single electron over comparatively long periods of time, such as in the calculation of the motion of cathode rays, but cannot be used to examine the motion of a single electron within a short interval of time." End of quote. This conclusion is only true if one thinks of the electron as a discrete particle moving from A to B in its orbit around the nucleus. However, if one thinks of the electron as a vibrating standing wave, then the theory of electromagnetism is relevant. In describing the atom, Heisenberg followed a particle approach and Schrödinger a wave approach. It is important to note that mathematically both theories, matrix mechanics and wave mechanics, were equivalent, but not ontologically equivalent. There followed a tug-of-war between the competing theories to explain the evolution of quantum systems and effects. Max Jammer, in his book The Philosophy of Quantum Mechanics, writes of Heisenberg's theory, quote, "It defied any pictorial representation. It was an algebraic approach which, proceeding from the observed discreteness of spectral lines, emphasized the element of discontinuity. In spite of its renunciation of classical description in space and time, it was ultimately a theory whose basic conception was the corpuscle." End of quote. And of Schrödinger's approach, he writes, quote, "Based on a familiar apparatus of differential equations akin to the classical mechanics of fluids and suggestive of an easily visualizable representation, it was an analytic approach which, proceeding from a generalization of the laws of motion, stressed the element of continuity, and as its name indicates, it was a theory whose basic concept was the wave." End quote. So the schism which developed over black-body radiation and the existence of the quantum deepened, and the main protagonists were not very polite about each other's work. Heisenberg, in a letter to Pauli, wrote, quote, "The more I ponder about the physical part of Schrödinger's theory, the more disgusting it seems to me." End quote. Schrödinger responded in kind, quote, "I was discouraged, if not repelled, by what appeared to me a rather difficult method of transcendental algebra defying any visualization." End quote. The main thrust of Heisenberg's criticism was that Schrödinger's wave equation, although powerful, throws overboard everything which is quantum theoretical, namely the photoelectric effect. The upshot was a strange compromise whereby the wave equation was accepted but reinterpreted by Max Born not as a description of reality involving wave phenomena, but as a probabilistic mathematical tool to preserve the notion of a particle as a discrete entity and to locate the probability of its whereabouts. Heisenberg was fully on board with this interpretation as it usurped Schrödinger's claims and enhanced his own. It is really this mathematical and ontological schism which manifests itself in all the ensuing experiments as evidence of an actual particle-wave duality and the heralding of a new age of physics, where the universe is not deterministic, but random, probabilistic, and containing weird effects. Schrödinger never accepted this interpretation and believed his wave equation described a real physical process. In a letter to Einstein, he complains, quote, "I am no friend of probability theory. I have hated it from the first moment when our dear friend Max Born gave it birth. For it could be seen how easy and simple it made everything, in principle everything ironed out, and the true problems concealed. Everybody must jump on the bandwagon. And actually not a year passed before it became an official credo, and it still is." Marabella points out in her essay Against the Stream how the Copenhagen cabal did everything they could to discredit Schrödinger. Quote, "After Einstein, Schrödinger was the most prominent and the most adamant opponent of the Copenhagen interpretation of quantum physics. As in Einstein's case, the Copenhagen orthodoxy trivialized Schrödinger's objections and understated his prominent insights. The Copenhagen physicists presented Schrödinger as a reactionary, hopelessly trapped in the deterministic, naively realistic modes of thought of classical physics. So Heisenberg won, at the cost of a coherent picture of reality. But Heisenberg was not finished, and continued to confound and confuse by introducing his uncertainty principle in a 1927 paper. It states that we cannot know the position and momentum, that is, its velocity times mass, of a subatomic particle at the same time. Therefore, the world is indeterministic and classical physics fails. Both Bohr and Dirac, together with a number of scholars since, pointed out the logical flaws in Heisenberg's arguments, noting amongst other things that as they were based on point particles and the conservation laws, then it is possible to work out both the position and momentum of a particle. But this did not prevent Heisenberg promoting his agenda, which included the goal of undermining Schrödinger. The upshot of this is decades spent pursuing chimeras and a great deal of utter nonsense being written, not only in physics, but spreading like a rash to the humanities. It is worth looking into the 1994 SoCal hoax, where a professor of physics at New York University, Alan Sokal, submitted an essay titled "Transgressing the Boundaries Towards a Transformative Hermeneutics of Quantum Gravity." He sent it to a cultural studies journal for publication. The essay was complete gibberish, but was published and is referred to as the SoCal hoax. There is a full account of this, together with articles by Marabella and Paul Boghossian in the scientific papers section of my website. If you want to find out more, please visit my website at quantumid.science, where you will find more in-depth downloadable essays, book lists, and original papers by some 19th and 20th century physicists. The next podcast is titled Atomic Circus, Jumps and Spins, which questions the Bohr model of the atom. I hope you can join me again in tracking down the true identity of the quantum.